Apparently, the globe is propaganda, and we are silly to believe in it. Hi everyone, welcome back to the channel. I'm Heinrich, the Real Nuclear Physicist. Today's video, we'll be taking a look at how Ali O thinks that Creaky is a globe propagandist and that how globe believers are just being silly.
This con man's doing more damage to the globe than most globe fantasists I know.
What on earth do you mean, Ali O? Has Creaky gone into his backyard and started to dig some holes, physically actually trying to damage the earth? Or are you just more general referencing he's been going around kicking globe models?
He's so bad, so dishonest, so useless, lies all the time to his viewers, either verbally or visually.
Creaky is everything but dishonest. He is a brilliant content creator, and calling him useless says more about your intellectual capacity than it does anything about Creaky. Creaky does not lie to his viewers, and the visual aids that he uses in his videos usually come from accredited sources. And he actually does research to support the points that he's making in any and all of his videos.
Even the average Joe in the street now has cottoned on to this guy and is highlighting the fact this guy's a liar, a con man, misrepresents people.
It's quite brave of a fluff calling somebody a con man when your entire identity revolves around you deceiving people about something as basic as the shape of the earth, and in the process trying to convince them that you are this being of higher intellect because you know something that nobody else knows, the real truth.
We've highlighted him before. We're going to continue highlighting this fraudster until someone on the globe side calls him out.
Did you know there are still people who believe the earth is flat?
Yep, there's many people that believe a flat earth.
Yes, there are still people who believe the earth is flat, no matter how many times it's demonstrated to them that it's not, even by their own peers. And yes, once again, it's Bob and Jeranism. And I'm thinking we can add Dave from DITRH to that list now as well.
But none of those people believe what you link to the words flat earth. Ridiculous maps, models, straw men, propaganda, lies and misrepresentations. None of them.
If what Creaky shows does not represent a standard fluff, I would like you to demonstrate to me and everybody what a standard fluff is then, without using any points that have been debunked by people like Creaky, Simon, Dan, Dave McKeegan, FTFE, and me. I'm pretty sure you'll find that what you call a standard fluff and what Creaky shows is a standard fluff is one and the same thing.
We're no doubt going to see some more propaganda linked to the words flat earth as you con your viewers and misrepresent people like myself. Like I say, I'm a demonstrable realist. The reason I go that way now is because of dishonest individuals like you, Sunshine.
The propaganda is repeated word by word from fluffs, and then we just come along and show you or tell you where you have gone wrong. Ali O, you always claim to be a demonstrable realist. And when somebody demonstrates reality to you where the earth is proven to be a sphere and not flat, you deny or refuse to believe it. I think you should stop calling yourself a demonstrable realist then.
What if it was? Well, if the earth were flat, gravity would work differently, or maybe not at all. Without the earth's spherical shape, gravity wouldn't pull anything towards the center.
Listen, I don't want to be rude, but listen to how retarded this guy is. Unbelievable. Listen here, Nookie Bear. No one denies the way reality presents itself to us. What you call gravity, whatever's at play there, gravity can be overcome by a gentle breeze. No one denies the way reality presents itself to us.
Insults will get you nowhere, Leo. You claim there is something pulling everything towards the ground, but it's not gravity. Well, what is it then? The reason gravity can be overcome by a breeze is because the gravitational force is directly proportional to mass. You don't see a gentle breeze blowing something heavy away, like a brick, or a car, or a house. You need stronger winds. Why? Because the gravitational force is stronger.
The daft heliocentric stories attached to the way reality presents itself to us are denied because they're quite frankly absurd. Gravity can be overcome by a gentle breeze, therefore isn't man enough for your fantasy world.
A Fleur, calling the spherical Earth absurd, is like an astrologer saying astronomy is absurd. Why? Because on the one part, you've got something that's completely crazy, like flat Earth and astrology, calling something that's proven and based on logic, like the spherical Earth and astronomy, absurd.
You, my handsome friend, are probably the worst globe representative I think I've ever come across. The tosh you come out with is ridiculous, embarrassing, so much so that you are waking up people left, right, and centre to the games at play.
If Creaky is the worst globe representative, then Leo, you are by far the worst Flurf. Even worse than CC. And that is quite a feat. Like all Flurfs, it just seems like you are a conspiracy nut. I'm guessing you also believe that there are powers to be trying to control the world, hiding the real truth from everybody, and you, like all Flurfs, are the only person who seem to notice this. Leo carries on about how Creaky lies and deceives, and fails to mention once how all Flurfs try to deceive the world and each other. So I think let's leave him there and we end this video for today. If you enjoyed this video, hit the like and subscribe button. I'm Heinrich, the real nuclear physicist, and I'll see you next time. Today, we'll be taking on 5 questions that Mark Sargent sent a scientist. Hi everyone, welcome back to the channel. I'm Heinrich and I'm the real nuclear physicist. Today's video, we'll be taking a look at Mark Sargent's 2018 Flat Earth Conference opening speech, where he claims that he sent 5 science-based questions to a scientist and they refused to answer.
Some months ago, a German television team contacted me because they had heard about my science challenge and had found a physicist at Georgetown University I could debate.
Let's start there. I highly doubt that anybody from a university would contact a flat earther saying that they found a physicist willing to take on your challenge in a debate. I think rather you sent them an email and said, I'm looking for a scientist, here's 5 questions, I want them to answer, please have them answer and get back to me. Any scientist won't debate something that's already established fact. Debates are for opinions, and it's usually 2 sides of an opinion. You don't debate something that's already proven, because then there's no need for a debate.
They also wanted to make it as easy on the scientist as possible, so their idea was simple. They would record me on video, reading 5 quick science-based questions, and then send that recording over to Georgetown, and he would respond in kind.
Well, there you have it. That's also not a debate. Sending somebody 5 questions and having them answer is not a debate, that's a response. Rather say you requested a response from a scientist rather than saying that a university contacted you to debate a scientist.
This is what I read on camera. 1. Long-distance photography. The mainstream science formula for the curvature of the Earth is 8 inches per mile squared.
That formula isn't quite accurate at all. It's a parabola. And even if the Earth is not a sphere, it's definitely not a parabola. Let's derive a formula that's a bit more accurate. Let's start with Earth having a radius of 6,400 kilometers. Sorry, I'm not going to do the miles conversion for you. With that radius, Earth has a circumference of 40,000 kilometers. This 40,000 kilometers means that 1 kilometer covers an angle of about 0.009 degrees. Using these values, we can calculate a height formula from the point where you stand as h, which is your height, is equal to r, the radius of the Earth, times 1 minus the cosine of the angle between you and your point. However, this equation is still not 100% accurate, as it does not take into account the viewer height or the refraction, but still more accurate than 8 inches per mile squared.
An easy comparison would be the falling rate of 32 feet per second, so 8 inches per mile per mile. 2 miles is 2 times 2 equals 4 times 8 inches, or 32. 3 miles is 3 times 3 equals 9 times 8, or 72, and so on.
So on and so forth. Yes, I understand what you're trying to say, but it's still a parabola. For accurate measurements of the hidden height, just use an online calculator. There's quite a few of them. They take into account refraction as well as viewer height.
At 50 miles, the curvature is 50 times 50 times 8, coming in at over 1,600 feet of curvature. And yet, with HD cameras, we can pull boats back into frame that are well beyond visual range.
Yes, you can pull boats back into view that hasn't gone over the horizon yet. This image of the boat, you'll never be able to pull that back into view, no matter how far you zoom in.
Not only does the new technology clearly show that it's not a mirage, but the same objects can be viewed in infrared and can be targeted ship to ship by beam radar. Can science explain this? They had no answer.
Yes, science can explain this, and in fact science was used to create this. Now, beam radars projected in a conical shape, with most of the energy at the center of the cone. This cone is projected towards the ionosphere, and it gets reflected to cover larger and larger distances.
Number 2, vacuum versus gravity. The force of a vacuum is measured in units of torr, T-O-R-R.
Now, vacuum force is a force proportional to the volume that is evacuated, whereas torr is a unit of pressure, not force.
Even a low-level vacuum can overcome gravity here on the surface.
Even your arms can overcome gravity when you have to throw them up in the air and say, I don't know what's going on. Why? Because gravity is the weakest of all fundamental forces. Gravity is proportional to the mass of an object, and the lower the mass, the lower the gravitational force. That's why it's easy to pick up a pencil, but quite difficult to pick up a mountain.
In building molecule-free chambers for the manufacturing of electronics, a series of massive pumps are needed to create a 99% vacuum. That's -9 torr.
A negative pressure value just means the pressure inside of the container is lower than the pressure on the outside of the container. Or, in other words, the pressure of an object is lower than the surrounding environment's pressure. Having said that, negative pressure just implies a vacuum. The more negative the value, the better the vacuum. But if we take space for an example, space is a near perfect vacuum. So there's nothing in the environment of space to compare it to get a -10 torr value. The space between Earth and the Moon has a value of 1 times 10 to the -11 torr, which is not a negative value, just a very, very, very small value.
And for the remaining 1%, horsepower isn't enough. It can only be achieved by a chemical leaching process. That being said, how is the -10 torr vacuum force of space not ripping off the atmosphere of this world?
The vacuum of space is not ripping the atmosphere of the Earth because vacuums do not suck. They are not vacuum cleaners. Gravity keeps the atmosphere from escaping, and as you go up in elevation, the atmospheric pressure gets lower and lower. That's why it's called a pressure gradient in our atmosphere. And as you reach the upper parts of the atmosphere, the pressure gradient is so small that it's basically a vacuum.
What is gravity? And remember that there are gases that already defy it, like helium, hydrogen, and fluorocarbons.
These gases do not defy gravity. In fact, they work exactly as expected in a gravitational field. I'm going to use a word that flat earthers are quite fond of using to try and disprove gravity, and that's buoyancy. Yes, helium balloons rise, but they do not indefinitely rise. And the only reason they rise is because there's an intrinsic force pulling the more dense atmosphere downwards. Helium reaches a height where the atmosphere above it is less dense than helium itself, so the balloon does not rise anymore. What's stopping it from escaping into space? You guessed it, it's gravity.
Isn't it more logical to suggest the atmosphere is being contained in an enclosed, pressurized system? They had no answer.
Well, if you think about it, gravity is our container. Gravity is the thing preventing the atmosphere from escaping. The fact that you keep saying they had no answer at the end of each question makes me think that either they had answers, you just couldn't understand what they were saying to you, or you made the whole thing up.
Number 3, eclipse shadow. Mainstream science tells us that the moon is over 2,000 miles wide, and yet during the 2017 American eclipse, no offense, the moon's shadow was only 70 miles wide, a reduction of over 97%.
I've already made a video on shadows and why the moon's shadow appears so much smaller than the moon itself. So please just go have a look at it. Here's a quick recap. The dark part of the shadow, called the umbra, is the part that we see during the eclipse. Now that's so much smaller than the moon because the sun is so much larger and further away than the moon is. If we take the whole shadow into account, which includes the penumbra, then the shadow of the moon would be much larger than the moon itself. But because you think that the umbra alone is the shadow, you think the moon should be 50 miles wide.
This is what the equivalent of having a 6-foot man walking in front of a wall where his shadow is smaller than an action figure at only 2 inches.
That would be a great analogy for this example. If the man walking past the wall was as proportionally far away from the wall as the moon is from the earth.
Where do we see this in our everyday lives? We've seen a shadow's actual size and some much larger. Where can we see small shadows? The Flat Earth community says that the moon is less than 50 miles wide, much closer and the same size as the sun. Isn't this explanation also possible? They had no answer.
If this is in fact true, and the sun and the moon is orbiting the earth so much closer than we actually think, please explain how eclipses work. Because if the moon would have gone in front of the sun, and they were the same size and the same distance away from the earth, then the earth would be in total utter darkness. If the moon was a light source on its own and would have gone in front of the sun, then an eclipse wouldn't happen because the moon would still be giving light. This is one point that flat earthers have been using to say that the earth is flat for a while now, and yet you haven't produced a valid model for why eclipses happen then.
Number 4, moon temperature. Science has yet to address this relatively new discovery that the moon generates a cold light. We all know that in the daytime it is 90 degrees in the sunlight, 80 degrees in the shade, depending on conditions. I know I'm not going to do the Celsius conversion up here, sorry. However, at night, especially when the moon is high in the sky, we see the opposite. While it might be 50 degrees in the moonlight, it's warmer at 60 degrees in the moon's shade, sometimes showing temperature shifts of over 13 degrees Fahrenheit. In addition, under controlled experiment conditions, magnified moonlight is even colder still, again, the opposite of sunlight.
I wouldn't say that anything from the flat earth community can be regarded as a discovery. The reason we reach warmer temperatures in the shade during the night is due to something called radiative cooling. Shadows are usually below something. As the heat from the earth rises up, it gets trapped. That's why it's warmer in the shade and cooler where there's no place for the heat to get trapped. Do the experiment on a night when it's new moon, where there's no moon visible at all, and you'll see that you still get the same results. Why? Because it's not the moon that's giving cold temperature, but it's the earth cooling itself down.
We can generate this with technology today using a cold laser. The question is, why is the moon giving off a cold laser light? They had no answer.
Well, the answer is the moon isn't giving off a cold laser light. Simple as that. Cold laser is just a term used for lasers that use low frequency light, but it's still light. Just like microwaves and radio waves also still light. Temperature is directly proportional to the energy of a laser, and the energy of a laser is directly proportional to the frequency of the light. Now, if it's a low frequency, it would have low energy, meaning low temperatures. That's where the term cold laser comes from. It's not a light that you can shine on something and it's going to freeze it.
Last but not least, the Van Allen belts. A simple yes or no question. Are the Van Allen radiation belts deadly?
Well, there isn't a simple yes or no answer. In short, the Van Allen belts can be deadly, but if you follow certain procedures when crossing them, you can get through them without incurring any harm.
If yes, then how did Apollo 11 through 17 make round trips through these belts with only aluminum and plastic as shielding?
Coming from a background in radiation sciences, I can answer this in my sleep. When working with radiation, there's 3 things to consider to protect yourself: time, distance, and shielding. Time, spend as little time as possible near the source. Distance, increase the distance to the source. And shielding, increase your shielding from the source. Now, you don't have to do all 3 to protect yourself, only one of them will suffice. The missions were set up in such manner that they missed the inner Van Allen belt, and as they reached the outer Van Allen belt, they sped up to spend as little time as possible in the outer Van Allen belt to reduce the exposure to radiation.
No one died, no one got radiation poisoning, nobody even got cancer. I think there's still like 5 left.
When being exposed to radiation, cancer is not a given side effect. Cancer is what we call a stochastic effect. Stochastic effect is when, if you expose radiation, the more radiation you are exposed to, the higher chance you have of contracting this effect. That still means there remains a chance of never contracting it, doesn't matter how much radiation you are exposed to. On the other hand, radiation sickness, a deterministic effect, which means the more exposure you get to it, the more severe the effect becomes. As I said, Apollo missions spent as little time as possible in the outer Van Allen belt, and that's the reason why they didn't get radiation sickness or cancer that we know about.
Radiation is only stopped by 2 metals, lead and gold. Both are very heavy and cannot be used in aerospace because of their weight.
Wrong again. Radiation is stopped by everything. In fact, there's some forms of radiation like alpha particles that can be stopped by a piece of paper. You can have alpha particles in a glass jar and hold it without the alpha particles ever even reaching your skin. Sure, lead and gold are better shielding materials than paper, but they're also not the only. Tungsten, for example, is even better, and uranium even better than tungsten. Now, in most hospitals, aluminium is used to shield for diagnostic X-rays, and we use something called a half-value layer, which is the thickness of aluminium needed to stop half of the intensity of the radiation.
If the answer is no, the belts are not deadly, then explain the video currently on the NASA.gov website called Orion Trial by Fire, in which NASA clearly states the belts are so dangerous they will not be testing manned capsules because they are unable to solve the radiation problem. Keep in mind, this is not an old video. It was created at the end of 2014.
When NASA says we've been to the moon, you're the first to jump up and say they're lying. But as soon as NASA says something that you think fits your narrative, you're the first one to jump up and say, see, they agree with us. You need to make up your mind. Either NASA's the enemy or they're the ally. They can't be both. The radiation problem that they mainly face is the effect that the radiation has on the navigation and the sensitive equipment that they want to send up. Nothing to do with the people in the capsule, but rather with the equipment.
The scientist viewed my recording and folded like a card table. This piece was never aired.
I highly doubt that this scientist even knew you sent them the video. Here I am, a scientist, and I'm not folding like a card table. Anybody with 2 brain cells to rub together will be able to answer these questions.
All that being said, my name is Mark Kendall Sargent, and I'm a flat earther.
Well, thanks, Mark. Now that you're done, so am I. Thanks everybody for watching. If you really enjoyed this video, hit the like and subscribe button. And on Thursday, we'll be taking a look at Occam's razor. You should really know that you're getting desperate when you're falling back on definitions to prove that the Earth is flat. Hi everyone, welcome back to the channel. I'm Heinrich, the real nuclear physicist. Flatswood went on a debate channel to debate Will Duffy and prove why the final experiment is not really an experiment.
So I'm going to argue against why I say the final experiment is not an experiment, as it's not scientific and it's only a false dichotomy. First, we have to look at the basics. What is science? Well, science, based on definition, is the systematic study and the structure of behavior of the physical and natural world through, note, observation, experimentation, and testing the theories against the evidence obtained.
That is correct, yes. And well done on your copy and paste of a definition of a word. But let me guess, you're going down the same path that Eric Dubay did by saying it's not an experiment, rather an observation. But please do continue.
So we have to observe what we're claiming, and then we have to do experimentation to make it called science. So do we observe the sun? Well, I agree. Yes, obviously we see the sun.
Yes, I agree. We do see the sun. There's nothing wrong with that.
What do we observe about the sun, though? Let's see. We observe the sun moving across our sky. We see that it gives heat energy.
Yes, we see it moving, but what we do not see is it giving off heat energy. We do not physically see the heat energy being given off. Yes, we can feel it, we can measure it, but we definitely can't see it.
We see it lights up the sky. We see divergent rays.
Yes, we see it light up the sky, and we only see divergent sun rays due to perspective. If you are looking top down, they would be pretty much parallel.
We see it following a circuit with its times and seasons. This should be interesting because since Will Duffy is a Christian as myself, and the Bible does talk about the sun following a circuit, it should be interesting to see how he will speak about this later.
The path the sun follows changes with season, but that's due to the Earth's tilt.
We see its change is in angular size based on the weather and just the angle movement. Sometimes you can see the sun huge at the horizon. Sometimes you can see it small. It has different optical effects. And yes, we are even able to show angular size change with lens caps.
We do not see an apparent change in angular size of the sun throughout the day. In fact, if you use a solar filter, you will see the size of the sun stay continually the same throughout the day. Which would not happen on a flat Earth. And on a flat Earth, the sun would definitely not get larger as it approaches the horizon.
So, next we have to make a hypothesis. What is a scientific hypothesis? A scientific hypothesis is a testable statement that is a prediction of the outcome of an experiment and is based on prior knowledge and observation. So we have to test it based on a prediction, and we have to do an experiment based on a knowledge of these observations.
We can also simplify the definition of a hypothesis, an idea that needs to be tested.
Okay, so what is a hypothesis, you might ask? Well, it's simple. There's just three very basic essential parts. The explanation.
Actually, a good hypothesis has two components, or two features if you'd like. Falsifiability, can it be falsified? And testability, can it be tested? But if you want to continue on this path, let's carry on.
This is the explanation is part of the hypothesis, which means you have to know the independent variable. The independent variable is the factor that the researcher has to manipulate to see if it affects the other variables. The other variables it will have to affect is the dependent variable. So the dependent variable is the other variable that is affected by the independent variable.
Yes, in simple terms, independent variable, what you change during the experiment. Dependent variable, what you measure during the experiment.
So what is an independent variable? Simple. It is the independent variable are directly manipulated by the researcher, while the dependent variables are not. They are dependent because they are affected by the independent variable in their experiment.
Yes, if we change the independent variable, we want to measure the effect it has on the dependent variable.
So, can we manipulate the cause in the final experiment? No. So not science. No, it's not an experiment. So therefore, we can't claim the final experiment as an experiment because it's not scientific.
Nice try, but we can indeed claim it as an experiment. Let's use independent and dependent variables, as this is what you are trying to explain to why it is not an experiment. The dependent variable that we would then have to test in this case would be the number of hours that we have daylight, or the time between sunrise and sunset. The hypothesis would then be as follows. During the month of December, as you move from the equator, which is 0 degrees latitude, south towards Antarctica, up to, let's say, 80 degrees latitude, which is where Union Glacier is about, we would see a change in the length of day, or the change in the length that the sun from sunrise to sunset. This change would go from 12 hours at the equator up to a maximum of 24 hours at a latitude of 80 degrees south. Now that seems like a great hypothesis to prove that this actually is an experiment. So let's leave Flatzoid here for himself to think of another way to try and prove the Earth is flat. If you enjoyed this video, hit the like and subscribe button. If you want to support this channel even more, share all my content with your friends and family. I would just like to give a huge thank you to my channel members and Patreon supporters. If you want to join this team, head down to the description. All the links are there. As always, I'm Heinrich, the Real Nuclear Physicist, and I'll see you next time.
Hi everyone, welcome back to the channel. I'm Heinrich and I'm the Real Nuclear Physicist. And today we'll be getting a lesson from a flat earther on time zones. The video we'll be looking at today comes from a channel called Flat Earth Banjo, and he's explaining how Professor Dave explains and Michael Sertain does not understand time zones. So let's see where he goes wrong.
So this guy, he came up with this, he uploaded a video a couple of days ago and talking about the Southern Star, and I'm gonna show you his video now, and I'm gonna show how wrong he is.
Somebody facing south, away from north, because this is your north in the middle there, right? Somebody facing south. This guy's facing south, over here. This guy's facing south, over here. All right, they're all facing away from north. And somebody in a boat here in the middle of the Pacific Ocean, okay? Somebody there also facing south. Now, they can all see the Southern Cross above the horizon when they're facing south. But for that to be possible on your flat Earth, look, it has to be there. It has to be there. It has to be there. And it has to be there. So it's sort of like Schrodinger's Southern Cross. It needs to be everywhere at the same time.
I agree. There's no time of day that it would be night in South Africa, Australia and South America. But it can be night in 2 of those places. In fact, take a look at this image. Now it's nighttime in South Africa and in the bigger part of South America. And once again, the claim now still stands. If 2 people, both of them facing directly south, both of them will see the Southern Cross. And that only works if the Earth is a sphere. Because on a flat Earth, they'll be looking in 2 opposite directions.
Pointed out to him that he wasn't in all 4 places at the same time. He was going around the table showing the star at 1 place at a time. So I went to timeanddate.com, I printed this and sent to him, and I told him that the Southern Cross was in Australia only at the same time he was making that video. One of the things he said that's really crazy is this one that he says the Southern Cross is observable in exactly the same place for the entire night.
I'm guessing, Flat Earth Banjo, that you're a Northern Hemisphere chauvinist. Because, just like in the Northern Hemisphere, Polaris is mostly stationary throughout the night, as it is the celestial pole. The Southern Cross is the Southern Hemisphere's celestial pole. Now, it's not the entire cross, and in fact it's not exactly at the cross, just a bit to the side of the cross. But it stays in roughly the same place throughout the entire night. It does not move across the sky, like Orion does, or like any of the other constellations do. So, how do you explain that on a flat Earth? In fact, a southern celestial pole doesn't even make sense on a flat Earth, because what is it rotating around?
Just like saying that you observe the sun standing at the same place all day, or the moon at the same place all night. And we all know that all the luminaries move from east to west.
Saying that the Southern Cross staying at the same place is like saying the sun and the moon would stay the same place throughout the day isn't even closely accurate. The sun and the moon move because the Earth rotates. Now, there's 2 poles that the Earth rotates around. What's at the end of those poles if you go into space? Polaris, more or less, and close to the Southern Cross. That's why they don't go around the Earth, but they more or less oscillate around the poles. So, once again, you can't explain that on a flat Earth, can you?
But I want to show you something really interesting, and you can go to my backup channel. I just uploaded this video there. It's a US Navy video, but, made back in the 50s, I believe, talking about celestial navigation. And they emphasize that all the celestial bodies seem to move from east to west, all of them. So please take a listen to this video.
They gave this sphere a name, celestial sphere, and we still call it that today. From Earth, it appears to move from east to west, 1 complete rotation every 24 hours. Polaris, or the North Star, is approximately at the celestial North Pole, and the rest of the sphere appears to revolve around it. The apparent motion is common to all celestial bodies. Their hour circles are constantly rotating from east to west.
Using data from the 50s isn't really something recent, is it? Yet, this still doesn't prove the Earth is flat. In fact, on that image showing Polaris as the celestial North Pole, the line going through shows there must be a celestial South Pole, which once again can't be explained on a flat Earth. And the fact that the stars seem like they don't move, it's because they are far, very, very far away. And light takes a long time to reach us. And we'll only see how they moved by the light that reached us. So it doesn't explain the flat Earth. And in fact, on a flat Earth, you don't even have an explanation for the stars. You just call them luminaries. What does that mean? What are they made of? Where do they come from? So please get get a decent explanation for your model, and maybe people would try to take you seriously.
When stars are used for navigational purposes, another reference must be used to determine their position. Stars appear to move, however, they do not change their position relative to one another.
Stars not changing their positions relative to each other is again because they are very far away. And we, rotating at a constant motion, will only see that the stars go from east to west because we are rotating. And that's not something you can explain. You don't have a model to explain why the stars are rotating.
Alright, so all stars are considered fixed because they are fixed. We don't have parallax between stars. On the heliocentric model, the star's position would change by the hour because, according to the heliocentric model, the universe is expanding.
Actually, we do. We do observe stellar parallax. If you look at a star during one part of the year, when we're at the one side of the sun, and then take a look at the same stars during 6 months later, when we're on the other side of the sun, you will see something called stellar parallax. Why? Because we're on a sphere rotating around its own axis, orbiting a sun.
The IRS inertial reference system in aircrafts wouldn't work. Nothing would work on an expanding universe.
The key word that you used there is inertial reference system. What does that mean? It's your inertial reference frame. It's a reference frame where the absolute motion is only your motion. So, on an aeroplane, their reference frame is they are moving. So the Earth, according to when you're in an aeroplane, isn't moving. Why? Because it's an inertial reference frame. That's why it works, because physics says it does.
So we have had the same star map, star chart for thousands of years. Stars do not move. It matches the flat Earth model observation, not the heliocentric model.
Making a claim that the stars have been the same for the last thousands of years is incorrect. In fact, because you're a Northern Hemisphere chauvinist, let's look at Polaris. So Polaris, currently the pole star, hasn't always been the pole star. The pole star, let's say 10,000 years ago, was Iota Hercules. And in about 1,000 years, we'll have another new pole star. So where does that claim from stars haven't changed position in thousands of years go now, when we've got evidence that the stars indeed did change?
And this guy on TikTok and neither Michael Certain or Professor Davis understand time zones. Those stars are never in all three places at the same time. They rotate. And the only time in the year that's possible for all three regions to see the Southern Cross, person has to be in the easternmost part of Brazil early in the afternoon. I mean, around 6 p.m. in the afternoon, evening, around 6 p.m. in the evening. And another person has to be at the westernmost part of Australia, in Perth, at around 5:30 a.m. and anywhere in Africa. That's the only time that the Southern Cross can be seen out those three regions at the same time.
Well, you say that Professor Dave and Michael Certain don't understand time zones, but it looks like you're not the one. And here you go showing an image proving exactly why you're wrong. So you go draw this Southern Cross at an arbitrary point on the map and just draw 3 lines to it saying that of course you'll see them if you're in those 3 places. But go do it on a flat Earth map. Then you'll see it doesn't make sense. And yes, that might be the only time during the year that you can see it from all three continents. But throughout the year, in fact daily, you can see it from at least 2 of them. And that completely destroys your flat Earth model. I think that's it for today. This flat Earth banjo has not shown in any way how time zones disprove a spherical Earth, or how Professor Dave and Michael Sertain don't understand time zones. In fact, it looks like he's the one who can't understand reality. So, if you enjoyed this video, like and subscribe, and stick around with me, and I'll see you next time.
On Tuesday, we took a look at a South African flat earther. And today we're back and we're keeping it close to home. Density, buoyancy, and gravity. These are concepts flat earthers have been struggling for quite some time. And they can't seem to wrap their head around that you can't have density and buoyancy without gravity. And it seems like we need to add potential energy to that list. Hi everyone, welcome back to the channel. I'm Heinrich and I'm the Real Nuclear Physicist. Today we'll be taking a look at how Flatzoid seems to think that Simon Dan does not understand density, buoyancy, and potential energy.
What is Mikey doing here exactly? I think his point, and the usual flat earther stance on this, is that his phone is denser than the air around it, therefore it falls. Well, okay, but my phone is also denser than the air above it. In fact, if you want to be really technical about it and really accurate, the air above it is very, very, very slightly less dense than the air below it. So why doesn't a phone move upwards if that's the case?
That is an excellent point, Simon Dan. And it's a question I am yet to hear a flat earther answer. Why is there an inherent down force? Density and buoyancy will only work if there is a downward force to oppose.
Glad you asked this, Daniel. Since you are Simon Dan and you claim to know so much about science and physics, it's weird that you would ask such a rudimentary question. Have you never ever heard of potential energy?
Yes, it does have potential energy when it's lifted from the ground. But the potential energy it has is gravitational potential energy, which is energy imparted to an object due to its position or relative position in a gravitational field. The equation for potential energy or gravitational potential energy is E, which is your energy, is equal to m times g times h. M being the mass of the object, in this case the phone, g, the gravitational acceleration, which is 9.8 meters per second, more or less everywhere. It does change as elevation changes quite slightly. And then h, of course, the height above the reference point. So if you move a 10 kilogram brick 10 meters above the ground, it would have 10 times 10, which is 100, times 9.8, which gives us 980 joules of potential energy. So, just like density and buoyancy, gravitational potential energy depends on, you guessed it, gravity.
Anyway, let's go to the basics. You see, this is Simon Dan holding his cell phone. Was his cell phone automatically in his hand? No, he had to pick it up. Now, what's going to happen when he's going to lift the phone? What happened? He imparted potential energy to the phone.
Yes, lifting the phone further imparts more potential energy to the phone. But the key word again is gravitational potential energy, not just potential energy, because we get different forms of potential energy. Elastic potential energy, chemical potential energy, electrical potential energy. So we need to be a bit more specific. And because we're moving in the gravitational field of the Earth, it's gravitational potential energy.
Now when it lets go, what's going to happen? It's going to turn to kinetic energy, and thus it sinks or falls, and depends on opinion.
If you let go of the phone, yes, it will fall. That's also due to gravity. But let's take a look at this example. If we disregard air friction, this is a prime example of the conservation of mechanical energy. And since you are from South Africa, I personally know that if you had science in school, you would have done this, because conservation of mechanical energy is part of the school curricula that we have here.
So yes, we see the phone is denser than the medium it is submerged in. Why would you expect it to go up just because it's less dense? It's still denser than from where you picked it up. Hence, it's out of its equilibrium.
If we drop the phone in a vacuum, the space around it would be infinitely less dense than the phone itself. Now the question is, what causes the phone to go down and not left, right, or up? That's why there must be an inherent down force, because something is pulling the phone down.
You know, when it's on the ground, it's in static equilibrium, or in your hand, again, static equilibrium, because you are supporting.
Might be in static equilibrium, but that does not mean gravity is not acting upon it. And like you said, the phone is being supported by the hand. So the hand stops it from falling because the hand is opposing gravity. Like I've said numerous times, gravity is by far the weakest of the four fundamental forces. Why? Because it's dependent on the mass of an object. So the lower the mass, the smaller the gravitational force.
So once you let go of the phone, you can no longer support it. Thus, the potential energy has turned to kinetic energy and seeks its relative equilibrium.
It's kind of obvious that if you let go of the phone, your hand is no longer supporting it. And yes, then it will fall. It would accelerate towards the ground. And guess what that acceleration value would be for the phone as it approaches the ground? 9.8 meters per second. And when something falls only under the effects of gravity, we call that free fall. Once again, something you would have done in science class.
The phone moves down for a reason. Why don't you ever think about that one, Mikey, yeah?
Like we've seen today, potential energy, just like density and buoyancy, is extremely dependent on gravity. Without gravity, these concepts break down. If you enjoyed this video, hit the like and subscribe button. I'm Heinrich, the real nuclear physicist, and I'll see you next time.